So here are the formulas. So the cosine of 2x, which means the cosine of the double angle, two different formulas that we can use, that we will use. So 2 times the cosine squared of x minus 1. Notice the relationship. Here's double angle on this side. This is just a single angle. This is just an x on this side. Okay? The other formula, the cosine of 2x, or the cosine of the double angle, it can also be written as 1 minus 2 sine squared x. So from the one side to the other on the equation, on the equal side, we're going from double angle information to single, or we're going from single to double. So I need you to notice that, okay? So it's basically showing us or telling us the relationship that's involved there with the formulas. There are other double angle formulas out there. We are only showing you these two, just to kind of keep things a little more condensed, because there's a bunch of different other formulas. So it starts to get confusing as to which formulas to use. So we've kind of condensed it a little bit so that it makes it a little bit easier. Okay? All right. I didn't put directions on here, but basically the directions are going to be, I want you to notice, I want you to look at each of these examples here. This is talking about the cosine of x and the sine of x, and then this one's also talking about the cosine of x. So those are all single angles, right? So if we're given the single angle, then the directions would say something to the effect of find the sine and the cosine and the tangent of the double angle. So our job is going to be to find sine of 2x and the cosine of 2x and the tangent of 2x. In other words, the double angle. Okay?
Why do we have to find all of them?
I thought it was great that we weren't going to have to find the reciprocal functions, the cosecant and the secant and the cotangent. But yeah, it's pretty common to pick. It's like you don't want to just find the sine. You're going to find cosine and tangent also. Okay? All right.
Well, really, if you have all three of those, then you also have the other three then.
Right, you do, but typically you're just going to be asked for the sine and the cosine and the tangent of the double angle if you're given the single. All right, I'm trying to decide. I do want to do this one. We're going to do this example, and we're going to do this example. This one will be in my notes on Canvas, but I want to make sure we have enough time to kind of talk through all of these. So we're not going to do all of them because I want to do two on the back page also. All right, so first thing I need for you to notice is that we're given the cosine of x. So we're given a single angle measure. I don't know, it might be helpful up here to kind of make a note to yourself. The left-hand side is the double angle. The right-hand side is the single angles. So if you're given a single angle, you need to be thinking about the fact that you need to be looking at the right-hand side and figuring out which formula we've got to plug into. So out of these two formulas, there's only one formula we can definitely plug into because there's only one that has anything about the cosine of a single angle. So the top one is the one we've got to use, isn't it? Good. Okay, so let's just write the formula out and then we're going to go from there in terms of determining what we've got to do. So the cosine of 2x is equal to 2 cosine squared x minus 1. That's our formula. And now we're going to plug in what we're given. We're told that the cosine of x is equal to 4 over 5. So that means we are going to plug in. It might be helpful if you want to or need to write it as 2 over 1 rather than just 2 to help you think about the fact that, what's in my numerator, what's in my denominator. So we plug in that 4/5. We've got to square that. So 4 squared is 16. 16 times 2 is 32. 5 squared is 25. So we get 32 over 25 minus, instead of writing that as 1, I want to write that as 1 only with my common denominator. So 25 over 25. So that it's easier for me to actually do the math here that's involved. So what we find is that the cosine of 2x, this double angle, is equal to 7 over 25. Okay. We're a third of the way done. From here, we are gonna, here's what I love about trig, and I've told you this before and you guys were like, that's why we don't like it. We're gonna circle back and use some concepts that we have used already before in this. So that's what I like, because it kind of goes back and helps you review some concepts. All right. Let's talk about the whole single angle to double angle business, because here's the deal. We have to figure out, we are told that the single angle is in quadrant 4. So I'm going to, off to the side here, I'm going to write that down. If the single angle is in quadrant 4, then that's somewhere between 270 degrees and 360 degrees. That's what that means, right? If we're in quadrant 4, we're greater than 270, we're less than 360. So to figure out where the double angle is, where this cosine value is, because cosine's positive in 2 different quadrants, we got to figure out which one it is, right, Alex?
Alex.
Sorry.
Okay, I'm sorry.
All right. 270, if we double that, gives us 540. 360, if we double that, gives us 720. So our double angle is somewhere between 540 degrees and 720 degrees, which that doesn't really help us because we have to figure out which quadrant we're in. So here's the beauty of these former concepts that we have learned before. We need to subtract 360 so we can figure out where this is. 360 is our, to help us find our coterminal angles. Hopefully that sounds familiar. So if we do 540 minus 360, we get 180. And 720 minus 360 gives us 360. So what this is telling us is that our single angle is somewhere in quadrant 4 between 270 and 360. If we double it, our double angle is somewhere between, using coterminal angles, somewhere in quadrants. Think about what quadrants this would be. We're either in quadrant 3 or we're in quadrant 4. But based on this answer that we just got here, if the cosine value is positive, which quadrant are we in? Quadrant 3 or quadrant 4?
4.
4. Because cosine values we know are negative in quadrant 3, but they're positive in quadrant 4. So if you need to make a little note here about the fact that we know then that we're in quadrant 4 over here, from those two things, that might be helpful. I don't know, you might want to do that. So what that tells us is that we want to draw our triangle to figure out these other values. We want to draw our triangle in quadrant 4. And instead of just putting an x here, I'm going to put a 2x. Our cosine value is 7 over 25. Now the beauty of this one is that this is a triple, if you can remember your triples.
Whoa.
There you go. Yay, Katie. She remembered it. It's also negative because it's going down. We're in quadrant 4, so that's the y value. It's going down. But now we can come up with our sine and our tangent values. So sine of the double angle is gonna be negative 24 over 25. And our tangent is gonna be negative 24 over 7. Arrow.
Wait, did you get the negative 24 because of the triples? That's how you get the
I
negative.
got the 24 because of the triples. I got the negative because I know in quadrant 4, this is going down, so it has to be negative.
So would you be able to see how that right triples? Like, could you solve it without?
You're gonna, yeah, Pythagorean theorem,
Yeah.
right? On some of these, you're gonna have to use Pythagorean theorem because they aren't a Pythagorean triple.
Brain break.
Okay? All right, I need you to kind of think about this. This part that you did right here, this math, very doable. Drawing this triangle and coming up with your SOHCAHTOA, very doable. So the only part that's kind of tricky is this quadrant business. We're gonna practice with it. It's new, it's different, I get it. So if you don't understand it right away, you just keep practicing with it and you will start to understand and kind of start to notice some patterns and that type of thing also, okay? But here's the deal. What I want you to realize and understand is I don't want you looking at a problem and saying, I can't do this at all because I don't know how to figure out the quadrants, because the quadrants is a small part of it. The quadrants is to help you decide on the signs, whether they're positive and negative. You can still at least do the math and figure out your, using Pythagorean theorem, what the lengths of the sides are and plug in and do that, okay? So I've had students in the past who they just totally freeze up and say, oops, I can't figure out how to do the quadrant thing, so I can't do these problems. Don't you dare fall into that trap, okay? All right, I'll put this one online, but I want to show you an example using the sine formula, because it's just so that you can see how we use that formula, because this is single angle, and so we have to plug into this second formula there, okay? All right, so we have cosine of 2x is equal to 1 minus 2 sine squared x. So 1 minus 2 over 1 times 1/3 squared. I'm going to hold off on how I write out that 1 for just a second. 1 squared is 1, times 2 gives me 2. 3 squared gives me 9. So because my denominator here is 9, I want to write this with my common denominator, so I'm going to write that as 9 over 9 instead of just 1. Okay. We know we're going to come up with the sine, cosine, and tangent of this double angle. Let's look at this information and figure out our quadrant situation and our sines. It's telling us that our single angle is in quadrant 2, so what are the degree measures that our single angle is between?
In quadrant 2,
In quadrant 2, what's our degree measures?
90 to 180.
Good, so 90 to 180. So that means if we double those, 90 times 2 gives us 180. 180 times 2 gives us 360. So notice once again, we basically get the same thing as we did up here, didn't we? Ultimately, we ended up getting that this double angle. So from different quadrants, if you double it, you could still end up in either quadrant 3 or quadrant 4, okay? So once again, please do not think this is always the case, because it's not. But once again, on this one, notice our sine value is positive, our cosine value is positive. So that means we're in quadrant 4 for this one also. Okay, so let's draw our triangle. So my double angle here. So my cosine, which is adjacent over hypotenuse. And I'm gonna figure out my sine and my cosine and my tangent. Okay, we've got to do Pythagorean theorem on this one, don't we? So 81 minus 49 equals y squared. So y squared equals, what is that, 32? So when we take the square root of that, that's 16 times 2, so 4. Whoops. Let's get that written correctly. Negative 4 root 2. So our sine is negative 4 root 2 over 9, and our tangent is negative 4 root 2 over 7. Yes, go quickly. We're gonna do a quick water break, and then I want you to think about what we did on this page, and then I want to show you the difference between what you see on this page and what you see on the second page, okay? So yeah, quick brain break. We were given single angles, so we plugged in to find the double angles. So on the next page, you're going to be given the double angles, and you've got to find the singles, okay? I'm going to pause this. On the notes on Canvas, I will have all of these worked out. We are actually only going to look at these two down here, number 3 and number 4. So I've written the formulas there just so that we have them back as reference, okay? Fix this typo for me. We're actually going to look at number 4 first. And there's a typo there. It says 2x in quadrant 1, I think, on your paper. I want you to fix it so it says quadrant 3. Okay. All right, so please notice now, we're given the double angle, which means we're plugging in on this side. We're plugging in on the left-hand side now. So we've got the math that we're going to have to do on the right-hand side, okay? So, yeah. The other thing to realize is that it's up to you which form of the formula you actually use. Personal preference. Because you're plugging into the left-hand side, it does not matter which form. I want to use each of them in one so that you can kind of see how the math works. But let's do, for this one, let's do the cosine of 2x is equal to 1 minus 2 sine squared x. Alex, there was a typo, so Alec. I keep seeing all of these x's, and so I'm saying Alex instead of Alec, sorry.
If you use one name in plural, then I guess it is Alex.
I know, that's true. Oh, I do teach multiple Alex. So, but I keep saying all of these x's, so I keep thinking x. Okay. We're plugging in now, think about this, we're plugging into the left-hand side. So we have negative 2/5 is equal to 1 minus 2 sine squared x. So let's think about the math here. Oh, let's change colors. Okay, I'm gonna need to subtract this 1 first, only on this side. Let's think of it as, whoop. All right, Ireland. Let's fix that. Negative 5 over 5 instead of negative 1, just so that I have my common denominator. So this gives me negative 7 over 5 is equal to negative 2 sine squared x. I'm trying to get sine by itself, so you can think of it as dividing by -2, but I think it's more helpful to think of it and realize we can also multiply by a -1/2. Because this is a fraction, I think it's easier to think of it as that -1/2. Okay, so we get a +7/10 is equal to sine squared x. And now when we take the square root of both sides in order to solve,
Why is it negative? Oh.
why is what negative?
Never mind, never mind.
Okay, so when we take the square root in order to solve, we get that. I want to keep that there, and I'll show you why in just a second. For final answer, obviously, we need to rationalize the denominator. So we would get the square root of 70 over 10. So we still have to figure out the cosine of x and the tan of x. All right, we need to decide on quadrant.
Why are you not doing the 2x's anymore?
Well, we're given the 2x, that's why we plugged in on this left-hand side instead of the right-hand side.
Okay.
So if you're given the double angle, then we're gonna find the answers for the single, the tan, sine, and the cosine of the single. Okay, so let's go back up here. This double angle is in quadrant 3. So quadrant 3 means we're somewhere between 180 and 270. So to think about where the single angle is, we got to divide all of those answers by 2. Divide all of those numbers by 2. So 180 divided by 2 is 90. 270 divided by 2 gives us 135. So we got to think about what quadrant that is. That's quadrant 2. Good. And what do we know about the signs, positive or negative, in quadrant 2 for each of these? So we know sine is positive, but our cosine has to be negative, and our tangent's going to need to be negative. All right? All right, so I want to draw my triangle in quadrant 2. And this is my single angle. Now, here's where I would rather use smaller numbers. So I'm going to use, for my sine, it says I can use the square root of 7 and the square root of 10. And those values are much smaller and easier to work with as opposed to a square root of 70 and a 10, right? So I want to use the square root of 7 and the square root of 10 here. Pythagorean theorem, this squared minus this squared, and then take the square root. So this becomes the square root of 3. And think about it, that's where the negative's coming from because we're going in this left direction. So technically that's what's negative, because remember this hypotenuse is always positive. So now our cosine value is negative root 3 over root 10. We need to rationalize that. And our tangent would be root 7 over that negative root 3. So when we rationalize that, we get negative square root of 21 over 3. Okay. All right. Questions, guys? We got one more we're going to go through, but I want to kind of... Alec is asking some good questions, but no one else is, which I'm glad he is, because I think it's helpful. But if you all have questions, you've got to ask too, to try to get this sorted out. Okay. kind of like, I want you to think about these problems. I want you to think about the fact that there's plugging in and some math to get your answer, and then there's drawing the triangle, and then there's the quadrant business, kind of the math you have to do to figure out the quadrant. So, sometimes I prefer to find the quadrant information first. Sometimes I wait. It's just kind of personal preference. Okay. All right. We're doing this one, and then we're done. Notice the beauty of this one is we're given the double angle. We're told where the single angle is already, so we don't have to do any work. How nice is that? So we know we're going to have to find the sine of x, the cosine of x, and the tan of x. But we know we're going to draw our triangle in quadrant 1. So we can set that up also already, right? Okay, so because I used the 1 minus sine squared formula there, I'm going to use the other one here. So cosine of 2x is equal to 2 cosine squared x minus 1. So I'm going to plug in okay. So I need to add that 1, only over here I'm going to add it with that common denominator. And instead of thinking of this as dividing by 2, I'm going to write it as multiplying by a half so that my fractions are a little bit easier to work with. So I get that we have 15 over 16 is equal to cosine squared x. So when I take the square root, in this case I already know I'm in quadrant 1, so the square root of 15 over 4, that's my cosine. So that means this is the square root of 15. This is 4. We've got to do Pythagorean theorem to get the other side. So we're going to do 16 minus 15 equals y squared. So this is just 1. All right, so my sine for this is 1/4. That's nice. My tangent is going to be 1 over root 15, and then we've got to rationalize. Yep. All right, what do you think?
Could you just do a different equation from 4?
I used the 2 different forms of that, yes.
Could you have used the one you used
I
for
sure
4
could
for number
have,
3?
yeah. For this one, I could have used the 2 cosine squared x minus 1. For this one, I could have used the 1 minus 2 sine squared x. You should still get the same answer. But if you're given the double angle, that's the beauty of it, is you can decide. I wanted you to see the math ends up being a little bit different when you're solving, so I just kind of wanted you to see that. So that's why I decided to use the 2 different ones.
So does it really matter which one you use?
Not if you're given the double.
Okay.
Now
If you're
think
given the
back.
single,
If you're given the single, you
Right.
have to use the specific
Right.
one that you're given. But with the double, it does not matter. Okay? All right, homework